Okay, so we're looking at question 11 from chapter 10, and it says a machine part has a shape of a solid uniform sphere of mass 225 grams. So we got that right here, 225 times 10 to the negative third kilograms, a diameter of 3 centimeters, so got that there. And then, let's see, it is spinning about a frictionless axle through its center, but at one point on its equator, it is scraping against metal, resulting in friction force of 0.02 newtons at that point. Find its angular acceleration for part A and part B. How long will it take to decrease its rotational speed by 22.5 radians a second? And so we've got the equation for torque right here, so it's going to be the radius times the force, which is equal to 3 times 10 to the negative fourth Newton meters. And then the moment of inertia is going to be 2 divided by 5 multiplied by the mass times the radius squared. And so we have that right here, 2/5 times 225 times 10 to the negative third kilograms multiplied by the 1.5, or the radius of 1.5 times 10 to the negative second meters squared, which is going to equal 202.5 times 10 to the negative 7 kilograms per meter squared. And and so when we plug that in for our equation for the acceleration, which is equal to the torque over the inertia, we get 14.8 radians a second squared. And then for part B, we want to know the time it would take to decrease by 22.5 radians a second. And so we have the change in angular velocity or angular speed over the torque. And so that's going to be 22.5 radians a second divided by 14.8 radians a second squared, which is going to be equal to 1.52 seconds.